Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a ketone is treated with NaNO2 HCl, nitrous acid, HNO2 generated in situ, the reaction is a nitration at the alpha carbon. The initial product is an alpha-nitroso compound, which tautomerizes to the more stable oxime form, is equal to NO. Moving on to the next step. Identify the starting material. The ketone is CH3CH2C is equal to O, CH3, which is methyl ethyl ketone butuvan. It has two sets of alpha carbons, the CH3 group, alpha on one side, and the CH2 group, alpha on the other side. Moving on to the next step. Determine which alpha position is nitrosated preferentially. In nitration with HNO2, the reaction proceeds via the enol tautomer. The more substituted or more accessible enol is attacked. However, the key factor here is that nitration preferentially occurs at the less hindered alpha position and yields the more stable product. The methyl group alpha, giving CH3C, is equal to NO, C is equal to O, CH3, involves the terminal methyl on the left side of the carbonyl. And for the final step. Mechanism. HNO2 from NaNO2 plus HCl acts as an electrophile, NO+. It attacks the enol of the ketone at the alpha carbon. The ketone CH3CH2C is equal to O, CH3 can form an enol at the CH3 end, CH3CH2C, O, is equal to CH2. Nitration here gives CH3CH2C is equal to O, CH2 NO, which tautomerizes to CH3CH2C is equal to O, CH is equal to NO, option B. Alternatively, enol formation at the CH2 end, CH3CH is equal to C, or CH3. Nitration gives CH3CH, NO, C, is equal to O, CH3, option A, or after tautomerization CH3, C, is equal to N or C, is equal to O, CH3, option C. Regoselectivity. Nitration preferentially occurs at the more substituted alpha carbon because the more substituted enol is more stable and forms preferentially, Brett thermodynamic enol control. The CH2 alpha position between CH3CH2 and C is equal to O gives the more substituted enol, trisubstituted double bond, compared to the terminal CH3. The enol CH3CH is equal to C, or CH3 is more substituted, disubstituted alkene than CH3CH2C, or is equal to CH2, monosubstituted. Nitration of this more stable enol at the alpha CH, the CH3CH is equal to side, gives, after tautomerization, the oxime CH3C is equal to NO, C is equal to O, CH3, which is option C. The nitroso intermediate CH3CH, NO, C is equal to O, CH3, option A, is unstable and tautomerizes to the oxime CH3C is equal to NO, C is equal to O, CH3, option C. This oxime is the thermodynamically stable product. Why other options fail? Option A. The nitroso tautomer is less stable than the oxime. It is not the major isolated product. Option B. This would arise from nitration at the less substituted terminal CH3, CH2 of the ethyl group, which forms the less stable enol, not the major product. Option D. This would be the oxime of methyl ethyl ketone at the ketone carbon itself, not an alpha nitration product. This structure does not arise from this reaction pathway. Therefore, the correct answer is C. Therefore, the correct answer is option C.